Hello everyone. Today in this session we would be learning about chi-square test. So chi-square test is a non-parametric test and today we would be seeing numerical aspects of it. We would be solving two numericals, one in theoretical aspect and one with SPSS. Also, we would be knowing about some of the characteristics of the test which are crucial in developing understanding about this test. So let's begin. So first question, in an anti-malaria campaign in a certain area, quinine was administered to 1,624 persons out of total population of 6,496. The number of fever cases are shown below. So what happened is in a certain area, the quinine, which the drug or the medicine that is used to treat the malaria, so it was administered to 1,624 person out of a total population of 6,496. So these many people were given it as a medicine while others were given a placebo therapy. So the question says is, while administering the quinine or after administration of quinine, how many people developed fever? Those were 40. After administration of quinine, how many people did not develop the fever? It was 1,584. After administering the placebo therapy or the person who were not given quinine, 440 people were such who developed fever. After administration of the placebo or those people who were not given quinine, 4,432 people were there who did not develop fever. And these are the totals. I would say that in this, these are the rows, okay, and these are the columns for developing of understanding. So now, when in research, when we see hypothesis, we have two types of hypothesis. One is H naught, which is null hypothesis. It states that there is no relationship, no relationship between the variables. Alternate hypothesis says that there is a relationship. So in this, we are seeing the relationship between quinine treatment, I mean the treatment and the development of fever or the healing aspects of it. So the treatment, how much effective is the quinine in treatment of malaria? So this is the main alternate hypothesis. So what happens is when we calculate the chi-square, when we add the chi-square test, it goes in certain steps. If I show you here, so okay, I had written it already, but again I would write for you all. So we calculate the expected frequency, we calculate the observed frequency, and we also calculate the degree of freedom. Okay, so first of all, we'll be calculating the expected frequency. If you see here, these are all the expected frequency. We would be solving it for developing the understanding. So first of all, just see what how the approach is being given. So first of all, see at this number 40. Now go towards the row and see what is the total of the row. Total is 1,624. Okay, so see here 1,624. Then see the column total. What is the column total? 480. 480. Now see the whole total. The here final total is 6,496. This is also mentioned in the question. So we see the row total first, then we see the column total, and finally we see the whole total of the data. This is the first value. 120 is the first value. Now we would be arranging it in a tabular format here. This is 120. Now we would be seeing the second number. So If you see here, what is the row total for this? 4,872. Total is 480 and final total 6,496. See here, row total, column total, and final total. The number is 360. Here you can see the 360. Now, again, we see this is the third number here. So this would be the row total. This is the third number. The row total this is 6,496. Column total is itself 480 divided by the whole total. Whole total is 6,496. So this is 480. And if you see here, we get the third number as 480. Now we go to the second column and the first number is 1584. The row total is 1624. 1624. The column total is 6016. 6016. And the final total is 6496. So get 1504. 1504. Again, this we would be proceeding in similar step for every number, seeing its row total, seeing its column total, and seeing its final total. And finally, we develop this table. So the formula is column total into row total upon the total number, total output. So that's how we are calculating these numbers and we arrange it in a tabular format. So these are our expected values in this. These are our expected values. Now the mentioned problem was our observed value. These are our observed values that during the experiment we observed these values. Then these are our expected values that statistically we are expecting these values. So we make another table and write down all these values: 440, 440, 1584, and 4432. Okay, these were our original observed value. Then expected values for this were for 40 it was 120, for 440 it was 360, for 1584 it was 1504, and for 4512 4432 it was 4512 as seen here. Okay, now we have to find out the difference of these two values, O minus E, and then we have to square it. So after getting the square, after doing it, if for example for one I am doing and rest all you calculate. 40 minus 120 square. 40 minus 120 is 80. 80's square is 6400. So this is the first value. Similarly, here we do it that 440 minus 360 is 80 only, and its square is 6400. 1584 minus 1504 is 80, and its square is 6400, and so on. Now, O observed value minus expected square, this value, divided by the expected value, we get these value, and we have to find the sum of all these value, which is 76.719, and this is the value of chi-square only. Chi-square's formula says observed minus expected value ka square divided by E, expected value. That gives us 76.719. Now, after finding out the expected value, what we have to do is we have to find this is our calculated value. We have to find a tabulated value, tabular or tabulated, tabular or tabulated value. So how to find this tabulated value? What we do is we have to find out the degree of freedom for that. Remember, I told you that in chi-square we only need three values. One is observed value, one is expected value, and third is degree of freedom. So we have already found observed, we have already found expected. Now we have to find the degree of freedom, which is new. So we would be going to the main table for that. Now, if you calculate here, how many rows do we have and how many columns do we have? So first of all, we'll see rows. This is one row. This is the second row. So in total, we have two rows. Now, how many columns? First column, second column. Remember, this is the total. This is the sum of these two values. So we have only two rows and two columns. For finding out the degree of freedom, what we will be doing is we have to subtract one from the row and one from the column, and then we have to multiply these two. So we had two rows, 2 minus 1 is 1, and we had two column, 2 minus 1 is 1. So 1 into 1 is 1 only. So degree of freedom for this numerical is 1. Now we would be going to the table. This is a chi-square table standard. You can find it in any on the internet itself or in any statistical book. So which covers the chi-square. So here you see the degree of freedom. Now remember that we had calculated the product of row and column, row minus 1 and column minus 1 for degree of, sorry, and column minus 1 to find out the degree of freedom, that is new. So we had got it as 1. Now we would be seeing this 1. And in social science and or humanities, we tend to fix this alpha level of significance at 0.05. So what happens is that when this much chance of error is there whenever we are involving a human element to problem. So the human tend to perform certain errors, and these errors are counted in this 5% error chances there, and 95% chances there that we would succeed. So if you see there here, the new value is 1 and the alpha level of significance is set at 0.05. So the value that we get is this. See from here and from here, 3.841. So as we scroll up, here you see that the tabulated chi-square value at 0.05 alpha level of significance, we get it 3.84. And the calculated value was 76.719. Since the calculated value of chi-square is greater than the table value, the hypothesis rejected. We can say that quinine is useful for treatment of malaria. This is treatment of malaria. So if you see here, what happened is the whenever we fix the hypothesis, okay, I have rubbed it, but whenever we see the hypothesis, that is H naught and HA, that is alternate hypothesis. H naught states that there is null relationship, and HA says that there is a relationship. So here the value of calculated chi-square is greater than the value of tabulated chi-square. And in that case, we can reject the null hypothesis stating that there is no relationship. Hence, the HA, that is the alternate hypothesis, is somewhat accepted. And we can state that hence we can say that quinine is useful in treatment of malaria. So this is the first numerical that we have performed. Now going to the theoretical or the characteristics of this test, we will be seeing here. So if we recall the steps, first we have to calculate the expected frequency. Second, we have to do the find the observed frequency, and then we have to find the difference between the two, and then obtain the square of the difference, and finally divide the numerator by respective expected frequencies to obtain the chi-square. If I show you here, we did the same. First, we find out the observed frequency, then expected frequency, then difference of these two, and finding the square of the two. Then the this value is divided by the expected outcome, and this finally gives us the calculated chi-square value. So proceeding forward, if we see what are the parametric tests. What is a parametric test? When assumptions about a population or type of population or parameter like population value are used for testing procedure, we tend to use the parametric test. If we talk about any parametric test like ANOVA, analysis of variance, we find out three groups, and we assign values like 1, 2, 1, 2, 2, 1, 3, 1, 2. Now, if you see here, we have three groups, okay, and we have three certain values associated to these groups. First person had something, say suppose these are marks out of 5. So if we say first person got 1 mark, second person got 2 marks, and third got 1 mark. In test A, okay, then we get in test B, we have 2 marks, and 1 mark. And test C, we get 3 marks, 1 marks, and 2 marks. Now, ANOVA says that we have to find the difference between these three and these three. Okay, one, two, three. For third person, 3 persons, we have three tests, and we have value 1 to 1, 2 to 1, and 3, 1, 2. Okay, so we have to find the difference in means of the three tests for these three people. You are seeing just related with these values. We have the parameters of the population. Like first person get 1 marks in the first this, second person got 2 marks in the A test, and third person got 1 mark in the A test. Similarly, first person got 2 marks in B test, second got 2 marks in B test, and third person got 1 mark. And similarly for three. So due to some technical error, this video is now being continued from here only. Now, if we see in situation where the non-parametric test is used, uh, we cannot make rigid assumptions about the population. Okay, uh, like in the previous example, we had three groups, three tests that were administered for person 1, 2, and 3. It was having, let's take some hypothetical marks, 1, 2, 1, 2, 1, 2, 2, 2, 1. Here we had some parameters of the population. Now parameters could have been the mean marks here. That if we see it for the third test, we can have 2 plus 2 plus 1 upon 3. Okay. So if we see here for the C test, the mean marks were 2 plus 2 plus 1, 5 but 5 by 3. So similarly, the mean marks for B test could have been 2 plus 1 plus 2 over 3. Another approach that we can see is how much difference between 1, 2, 3. So for 1, the mean marks could be 1 plus 2 plus 2 in all the tests upon 3. That is 5 by 3. For 2, it could be 2 plus 1 plus 2 upon 3. That is 5 by 3. So the main, and similarly for 3, the main motive for telling this marks pattern or the differences in mean is that we can estimate the uh, parameters about the population, the about population. Okay, so how much they are performing in A test, how much they are performing in B test, how much they are performing in C test, or how much one is performing in all the test, how much two is performing in all the test, and similarly for three. So these determine the parameters. But when we talk about this non-parametric test, what happens is we generally make use of categorical variables. Categorical means that we associate the total numbers in categories. Okay, so for example, if we talk about color, okay, so we have say the preference is red, blue, and green. So say there are 40 people who prefer red color. There are 20 people who prefer blue color. There are 30 people who prefer green color. So can you tell, we are not able to tell about the perfect parameters. We are just relating the categories of the color to some people. So in such cases, we are not able to make rigid assumptions about the population, or we cannot tell rigidly about the assumptions of distribution. Now, as in case when we use parametric test, we have a normal probability curve or NPC that follows a distribution if the data is parametric. So there are certain assumptions that this curve follows, and that assumptions are applied on the parametric test, like ANOVA or any other parametric test. But in case of non-parametric test, these curves can vary. It can be of some form like this. This can be of a long-tailed curve, and it depends on degree of freedom also. So we will not go into that much discussion, but these curves may vary according to degree of freedom or according to the shapes also. So going to the next point, non-parametric test is a distribution free. As I already told you that they follow parametric follow a distribution pattern, whereas non-parametric are distribution free. They can follow any distribution depending on the data. These are usually computationally easier to handle and understand. They can be used with type of measurements that prohibit the use of parametric. If the parametric test is not able to uh, solve the problem, or it is not the parameters are not available, we tend to use the non-parametric test alternative of that alternative of that parametric test. So chi-square describes the magnitude of discrepancy between theory and observation. As we have already solved the question above, we can see that we can see the difference between the or the discrepancy between the observed and the expected. This is chi-square. So by this, we have come to the end of the theoretical aspects or the characteristics of chi-square test. Now we would be going towards solution in SPSS. Now we proceed on to the statistical part of the chi-square test using statistical tool like SPSS. Okay, so statistical package for social science is its full form, and it has some symbol like this, if you can see on the screen. So we have a data, hypothetical data on drink and drive accident cases during night driving in urban areas. Uh, this is a self-generated data. It has no credible reference to it, and it tells us about the drink and drive accident cases in urban area. We all know that if you drink alcohol and then drive, then it there are high chances or high probability that somewhere one can meet accident. So this data is somewhat biased on that aspect without any reference. So what we'll be doing is we would be statistically analyzing this data using chi-square test in SPSS. So SPSS interface looks somewhat like this, and we have to define the variables first. So drinking and accident. We would be copying this whole data and pasting it at spss. So we have pasted the data. There are two variables. Variable one is drinking and second is accident. So yes is the person who has drunk and A is for accident. Yeah, the person drunk and met with accident. Similarly, the person has drunk but not met an accident. So we'll be defining the variables here. Drink status and accident status. Okay. So these are this is a string data, a nominal data, so we will keep it as string only. Now, what we will do is we will go to analyze descriptive statistics, cross tabs. Now, you can assign any row or any column, it doesn't matter. So, we will be taking drink status here and then column is accident status. Okay. Now, click on statistics. We'll perform the chi-square test and we'll choose the Phi and Cramer's V. This is for this is for generalization. How much you can generalize the data, we'll be seeing it in results. Then we have cell and observed and expected. Then continue. Nothing needs to be changed then and okay. So this is the output of the chi-square result that we are seeing here. If you can see the table is made for us, the drink status. No, the person, how many of the person have not drunk alcohol and met with accident? This number was 4 in observed value. This is the observed value. Then how many people have not drunk the alcohol and have not met the accident is 10. This 10. This is the observed value. Okay, so this correlates with the data that we have fed here. So total number of this drink status and accident. Now, according to the data, the expected count should have been 8.4 and 5.6, but the actual count that we have observed is 4 and 10. Then drink status. The person who has drunk the alcohol and met with accident, there are total number of 20 people here. And the person who have drunk alcohol and could safely reach home and not met with an accident, total is 6. So these are observed value and the expected value for the same could be 15.6 for uh, person who has drunk and met with accident and 10.4 for person who have not drunk and met with not met with the accident. So so the value, if you see here, the p value for the experiment is less than the level of significance. Remember, the level of significance fix for this experiment was zero point 0.5, 0.05. So here the value is much less than the level of significance, and that accounts for acceptance of the alternate hypothesis. That means that there is a relationship between the drink status and the accident. We can say that a person who is not drinking would lead to less number of accidents. And so we would be reporting it as rejection of null hypothesis. That means that there is a relationship between drink status and the accident. So That's all from my side. There are much more to this explanation, but due to time constraint, we are limiting ourselves to this discussion only. So thank you very much. Stay tuned for more.